Hello friends, welcome back. I am Rajneesh and today in this session we shall continue our discussion with the memory. So in this session we are going to understand the overcommitment of the memory. By default in Linux kernel, whether it's Ubuntu or whether it's RHEL or CentOS, the overcommitment is allowed heuristically. That is, depending upon the requirement of the application that is trying to access or that is trying to allocate the memory. Commitment or overcommitment means, okay, overcommitment, what does it mean? We have 4 GB of RAM, we have 4 GB of swap, but still the operating system can allocate the memory more than 8 GB. That is overcommitment. Because if we talk about the total RAM plus swap that we have, it comes out to be around 8 gigs. But in the last session we had a look into it that we were able to allocate more than 10 or 15 gigs of virtual memory to the application. So is there any possibility that we can restrict that? We are going to see that part in this session. And second part that we are going to look into is the overcommitment of huge pages. Last time we understood what huge pages are. By default the page size is 4K, but if we are talking about huge pages the size was 2M. Okay, so let's have a look into it. How will you come to know what's the size of page? So simple command getconf -a and grep -I page. So here you can see the page size. The size of the page specified over here is in bytes. So this page size is 4 kilobytes or 4K. But if we look into procmeminfo, here we can see the size of a huge page. So it is 2 megabytes. Okay. So why do we need huge pages? The reason is by using huge pages we can have less number of page entries, less number of entries in page tables, which simply means we'll have to scan less area, means faster access. Okay, so coming on to our discussion with overcommitment, let's try to understand it. I would like to open two sessions. One session we'll use to display and other to modify certain parameters. Second is to see what's the impact is. Watch it every 1/10 of the second. So procmeminfo grep -I commit, sorry my mistake. So here we can see commit limit and committed address space. Commit limit, maximum amount of virtual memory that can be allocated to all the processes, or the aggregate of the memory that can be allocated to the processes inside this OS. So right now it's restricted to nearly 7.3 gigs. So commit limit comes into picture or impacts only in the case when we have certain value of overcommitment, like okay, if we are talking about overcommitment, we actually have three variables in sysctl parameters that impact it. One is associated with the huge pages, that impacts only the huge pages. Right now there is no overcommitment for the huge pages. Fine. If we talk about, okay, uh, do you want to see an example of huge pages before that? That would be great. So I'll stop it and we'll have a look into so here we see total number of huge pages which are available is 10 and all of them are free. We are going to reduce them to /etc sysctl.conf where we set it last time. I'm going to reduce it to 2. To reload it, sysctl minus p. So now the total number of huge pages I have is 2. 2 of them are free and the size of each huge page is 2m. So maximum amount of huge pages that can be allocated are corresponding to 2 to the 4, which is 4 max. If I run my huge pages script, it tries to allocate 4 pages and it's not able to allocate because we don't have any overcommitment of huge pages. So in case you want overcommitment, there are two approaches to modify sysctl. The best is you modify sysctl.conf and reload it so that it will be available after the boot up. In case you want to modify sysctl parameter on the fly, you can set it sysctl minus w parameter equal to value. So here you see that you have enabled overcommitment of huge pages for up to 2 pages. So let me try to run huge pages now, and here we can see that the total number of huge pages have been increased to 4 because 2 overcommitment up to 2 huge pages is allowed by enabling this parameter nr underscore vm underscore overcommit huge pages. So here you can see the total number of huge pages increased to 4. 4 of them are free, but they have been reserved, means they cannot be used by any other application. They have been reserved by this huge pages application, this one. So here it shows you surplus also, means the extra pages over the pages that were visible available to it, because huge pages that were available were 2. So additionally it got 2 from the overcommitment of huge pages and it became 4. So start writing, and here you see all have been used and there is nothing free as of now, nothing in huge pages as reserved. As soon as you press enter, they are all cleaned up, and here you can see that the total number of huge pages you have is just 2. So 2 were received from overcommit dot huge pages. Okay, so this is how overcommitment with the huge pages happens. If you want it to be persistent across reboot, you can just modify sysctl.conf and add this variable at the end, and now this value will be available after every reboot. Write and quit. So this is how the overcommitment happens with huge pages. Now coming on to the commitment of the memory or the commitment of the virtual memory. Sysctl minus a grep minus I overcommit. Now if we are talking about the overcommitment of the virtual memory, it depends upon both these two variables. First of all, in case the variable overcommit memory is set to 0, this means that overcommitment of memory is done on the basis of heuristic factors. In case the application is asking for a memory that is not that is more than your RAM, that will be allocated not an issue. But in case the application is asking for too much of RAM, 100 gigs or so, it will think it is asking for too much of RAM and will not be allocated. If you want to see the documentation about it, go to user share doc linux docs vm overcommit. And if you want to see the same thing in RHEL or CentOS, you'll have to make use of kernel doc over here, user share doc kernel docs. And here you see the values corresponding to overcommit sysctl parameter. 0 says heuristic overcommitment handling. Obvious overcommits of commitment of address space are refused, used by default as we had a look into it. So it ensures that seriously wild allocation fails while allowing overcommitment to reduce swap space. Okay. So if we talk about second value, which is always overcommit, so how much of RAM you ask for, you will always be allocated that amount of RAM. You ask for 100 gigs, you will be allowed 100 gigs of virtual memory. And of course, when you will try to write to that, you actually when try to access that or map that to the frames, then you may get out of memory because the actual RAM that you have is less as compared to the virtual memory. That's why we want to restrict it. And there is a final variable which is the value which is 2, which says overcommit but to certain limit. For example, you have some swap space and some RAM, so it will be a combination of swap space plus some percentage of RAM, after which the overcommitment will not be allowed. So it says don't overcommit. The total address space limit that can be used or the commit limit that will be visible to you will be the addition of swap plus some percentage of RAM. So system is not permitted to exceed swap plus some percentage of RAM, which is specified again as a variable overcommit ratio. So by default it's for 50 for most of the operating systems. Just now I changed it to 100. So here we can see our commit limit is nearly 7.5 GB. What it means? It means that I can access the address space up to nearly 7.5 gigs. If the applications are asking for the virtual memory and that overall utilization or the committed address space increases this limit, it will not be allowed to increase the limit. Right now you will be able to, I'll show you an example. So eatmem virtual 4096 m. So here you see committed address space, the virtual memory or the address space currently allocated. So it comes out to be nearly 4.3 gigs. I take 4 more gigs, so it comes out to be nearly 8.5 gigs. So here you can see that the committed address space or the address space or the virtual memory that is used by the applications is more than the commit limit. The reason is overcommitting is allowed on the basis of heuristic criterias. Got it? Okay. What if you don't want the applications to utilize more than commit limit or more than a particular limit of memory? So even if we are talking about the virtual memory allocation, that should not exceed a particular value. In that case, we would like to modify this variable overcommit memory to 2 so that it won't overcommit after this commit limit value. So when we set overcommit memory variable to 2, it simply means we are going to restrict the operating system to make use of maximum virtual address space, which is equal to 7.4 GB or equivalent to commit limit. After that, the memory management unit will not be allocating any more virtual memory to any more process. So let's try to modify this variable and see the impact. So as soon as I freed up this 4 GB of virtual memory, it drastically reduced from 8.5 to nearly 4.3 GB. So right now the committed address space has been reduced to 4.3 GB. So now our objective is applications should not be able to make use of RAM above 7.4 gigs. So what we are going to do is, first thing, we are going to set the overcommit memory variable to 2. So it makes sure, now you can see that the value has been changed to 2. It simply makes sure that now the at bar has been placed in the memory on the virtual memory, so no virtual memory can be allocated after the memory utilization or the virtual memory utilization has been increased to 7.4 gigs. So this is a tapping that has been implemented on virtual memory. Okay, if you want to implement it and if you want it to be available after every reboot, you will have to modify sysctl.conf and add it at the end. Okay, now the second part that is impacting is overcommit ratio. If you see to free minus m, here you can see that the swap space is around 3.6 gigs and RAM is around 3.5 gigs. So, and here you see overcommit ratio is 100, which simply means swap plus 100% of RAM. This is going to be the value for commit limit, so it comes out to be nearly 7 gigs or so. So here you can see that the commit limit right now is nearly 7.4 GB, and let me try to run some application that tries to make use of, or that tells the operating system or the memory management unit to allocate 4 more gigs of RAM, because if you add 4 gigs to it, it is going to cross 8 GB of RAM utilization or virtual memory utilization. So I just type eat virtual memory by 4 GB and it fails because it was crossing the limit of 7.4 GB of commit limit. So the other part that, okay, let's try to allocate 2 GB, and it succeeded. And here you can see that the address space is now increased to 6.4. If you want to confirm the memory utilization or the virtual memory utilization by this application, you can use ps ax all the process with specific options, command rss resident set or actual RAM, and vsz. And here you see that it's utilizing nearly 2 gigs of virtual memory. Now I just click it, kill it, so here I kill it, and committed address space is now reduced. Now if you want your applications to make use of nearly 10 gigs of virtual address space, then we may have to increase the variable which is overcommit ratio. So if you set it to 200, it will add nearly 3.5 gigs, which is equivalent to the RAM, to this commit limit. So it is going to cross 8 plus 3 11. It is going to reach nearly 11 gigs. So let me increase the commit ratio to 200. So here you see, as soon as I increased it to 200%, it means swap plus 200% of RAM. So whatever value was there previously was increased by nearly 3.5 gigs, and we reached to around 11 gigs. So 7 plus 3, 10, it comes out to be nearly 11 gigs. So now the operating system or the applications inside the operating system can utilize or can access up to 11 gigs of address space. So now if I try to allocate 4 GB, and if I see it here, I can see that 4 GB is now allocated. 4 GB virtual memory is allocated because we still have some memory left in commit limit. So I can still see that it's around 2.5 gigs can still be allocated. So here you can see that there is still around zero point 0.5 gigs which can still be allocated. So here what you do is, there are two variables associated with the overcommitment. One is overcommit ratio, which specifies the percentage of RAM. 200 means 200 percentage of RAM, which means double of RAM. So 7 GB plus swap, which is 3.6. So it comes out to be nearly 11, 7 plus 3, 10, nearly 10.6 GB of RAM, which comes out to be commit limit. So commit limit is actually swap plus this percentage or 200 percentage of RAM. So this is the tapping for virtual address space that can be set. But if you want to set this as a tapping, you need to make sure that you modify the variable overcommit memory to 2. In case this is 0, it is going to heuristically allow the applications to have access to more address space or more virtual memory. In case you set it to 1, it will always overcome it. In case you want to set the tapping to commit limit, we need to set this variable to 2. Okay, and overcommit ratio is the value of commit limit is swap plus this ratio or the percentage of memory. 200% of memory comes out to be 7 GB plus swap space. And we had a look into the demo where we tried to allocate virtual memory, and we were not able to allocate because, or the application gets out of memory, it got killed because it was not allowed to allocate that amount of memory. Okay, so yeah, that is all for the session. Thanks for viewing the video. Have a great day. Bye.